Okay, this is an example of data set, iris data set. It's actually 150 flowers, 150 flowers data set. The flower's name is actually iris. In this table, actually it's a table. There are 3 types of flowers: Iris versicolor, Iris centrosa, Iris virginica, right? And the first 4 are attributes, or you can call it as features. So as you can see, the first one is what? Sepal length. So this is sepal. This is petal, right? So that's a sepal length and sepal width, petal length and petal width. These are features. And then we have species. Species is actually our target. Yeah, our target or label. Okay. So later on, someone will give you a value of sepal length, value of sepal width, value of petal length, value of petal width, and then you are supposed to tell what type of species it is. So it's a predictive model. It's actually a classification problem. Yeah, what type of class? There are actually 3 classes here. Your machine learning, given example x1, x2, x3, x4. Your machine learning is supposed to tell you, is it type A, let's say this one A, type B, and type C. Machine learning will tell you. So it's a predictive model. It will predict to you which one is it, A, B, or C. Okay, an example of classification problem. Okay, a little bit more model. I just told you just now, like a predictive model. A model represents a relationship between feature and label. Somewhat we call it the relationship. So as you can see here in the previous slide, I explained. Okay, you are given this. It gives you either A, B, or C. So there's some sort of relationship that the model has created, right? A means this, B means this, C means this. And a model usually we call predictive model. Yeah, predictive model. So after this, when you Google, if you bump into predictive model, you know what exactly it is. So in order to develop this predictive model, we have to do training. We have to do, after training, we will do inference. So what is the training? A process of learning the model using the label samples. You will give all the data inside, it will learn and will create a model. Okay, that's a training process. And inference, apply the trained model to unlabeled samples and making useful predictions. Yeah, so once you have the model, you have a new data set, push it in and ask it to predict. Of course, you have your real answer. You'll compare and see the accuracy of your model. So those are all fall under inference. Okay. Okay, so I explained just now. Say given x1, x2, x3, x4, find the species of the flower, right? An example of a predictive model. Okay, why do machine learning? Okay, the answer is that we're pretty much in front of you. Growing quantity and varieties of available data, cheaper and more powerful computation processing power. Tasks sometimes very hard to do by human. For example, I ask you to calculate number of humans in the picture just now, right? So it can be done easily by machine learning. Of course, it is now being used widely in various kind of organization and industry. Okay, so it's very much like, for example, the apparent ones are self-driving cars, right? A lot of all the robots, etc. So this is a real world application of medical images to diagnose whether it's a cancer or not. And image recognition, your phone can unlock with just by you appearing in front of it. Yeah, email spam filtering. So again, here spam filtering, the label will be spam or not spam. So that's an example of label. Online fraud detection. Online fraud detection is basically finding an odd individual or an odd customer who does a different kind of like online transaction, for example, right? So that is more on online fraud detection will work well with clustering machine learning methods. Traffic prediction, you can do simple regression, and so on and so forth. Yeah, the application is just humongous. Okay. Now, the machine learning project workflow. First, we start with problem scoping. So we know specifically, we have specific questions that we want to answer. And then, of course, based on that, we are going to collect data. After collecting data, the first step would be data preparation. Yeah, you have to clean up the data a little such a way that you can then push it to machine learning models. So then, of course, here will be machine learning model that we develop. Next is we are going to evaluate the machine learning model. After evaluating, we will double check, verify. When it's okay, then we will deploy. Right. For example, simple model will be a YouTube recommender system. YouTube recommends for you all the videos and clips that you want to watch based on your previous history, right? So that's actually a recommender system. So the model is like, the more you watch, the more it tunes such a way that it recommends you the right clip to watch. So you are supposed to watch for 10 minutes, you end up watching for 2 hours, right? So it's that good. Okay, so this is how it works. And it's a cycle. It's not like one time go run and then that's it. End of the day, it's just done. No, right? The more you watch, the more it is going to tune, right? The more it's going to tune. So until it becomes really good. Okay. So basically, this is what we will do during this course. Okay. We're done the first part. The first part is basically just understanding a little on data, then understanding a little on the machine learning, keywords, and etc. Next is type of learning. Type of learning. So I did talk about on all these matters. Let me just go straight here. Okay, all those are explanation which I did earlier as well, right? So there are actually how many types here? First is supervised learning. Second is unsupervised learning. Third is semi-supervised learning. And finally, we have reinforced learning. So these are the types of machine learning methods, right? So machine learning. So we can see all are some different kind of learning. Just that now machine we refill with supervised, unsupervised, semi-supervised, reinforced, right? Any pictures here? Okay. So supervised learning are those with target. Data with target and label. Unsupervised learning, no target, no label. So supervised learning means here you give data, you say this is it, this is the answer. You give question, you give all these features, you say this is the answer. That is supervised learning. Unsupervised learning, you don't give any target, you don't give any label. Just give the data. It will tell you, for example, there are actually 3 groups in this data. 3 groups of customers in this customer's data. 3 types of customers, for example. That's unsupervised learning. Okay. Supervised learning that we are going to cover would be on regression. The other one we will cover on classification. The output for regression will be a real number. The output of classification is just class. Class means it can be an integer. Regression. Tell me predict me the weather today, the temperature today, 32.5. That is regression. Tell me whether the student will fail or not based on all these marks. That is classification. Tell me whether the email is a spam email or not. That is classification. You see the difference? All these are supervised learning. We have upfront some sort of data. This means spam. This means not spam. Okay. So using that, we will teach the model and create a predictive model. Whereas unsupervised learning, an example would be, I take all the students' data set that I have, I push it into this unsupervised learning method, for example, clustering. And I ask the machine, how many groups of students in here? That is clustering. Semi-supervised would be, you do give some sort of information to the machine and then it learns. That is semi-supervised. Reinforced learning would be a method where when the method does the right thing, you reward the method. When it does the wrong thing, you penalize the method. So basically, we intervene and give reward, and we penalize the method. So that is reinforced learning. These are the 4 main methods of machine learning. So in this course, we are going to cover 1 and 2. A little bit on 3 as well, but they are not going to cover on reinforced learning. Okay. All right. So that's the story. Yeah. Whatever that I explained earlier is written in here, so you can read it out. Okay. For example, here, as supervised learning, we have actually data is the image, and we have labels, either cat or dog, right? Cat or dog. I have many images and many cat and dog. That's why it's called label. Okay, label. And then we push into algorithm, we get a model. Okay, so we get a model. Then once we have the model, of course, we have to check also. You have to check, you have to verify whether the model is doing the right thing or not, check the accuracy. And after that, you give a new image to the model, and the model will tell you how many labels here, either cat or dog. So it's a simple example of regression or classification. Regression or classification? Classification, right? Okay. Okay, examples. Yeah, classification examples, regression examples. Okay, so you will get some data, and you'll do this work when the time comes. So unsupervised learning, yeah, basically trying to figure out the hidden structure. Yeah, the hidden structure here. When I say structure, hidden groups. How many groups in here? Those are all structures of the data actually. Okay. Unsupervised learning. So around there's no label. I don't know whether this is cat or dog. I have got 6 images. I push it into the algorithm, and then I get the model. It's a bit hard to check whether the model is doing the right thing or not. I wouldn't know. I cannot check the accuracy, but rather I get to see the groups. Also, you see this group 1, I get 2 groups. Group 1 is this images. Group 2 is this images. By looking at the images, I'm going to investigate, see, oh, actually a group of dogs and cats. Okay, this is called unsupervised machine learning. So we didn't teach the machine. We didn't give the label. It did it did clustering itself. Okay, it's clustering. All right. So types of supervised learning, I was explaining, saying that, okay, clustering. Okay, recommender system, whatever that YouTube does, right? Customer segmentation, the number of groups of customers that I have in my data. Targeted marketing, So once you have, the customers group, different customers, you can target different way to market your product. Okay. And then dimensionality reduction. Your data sometimes is so huge. Yeah, your data, for example, let's say you have data, I say I have a student's data, student 1, student 2, until student n, and then their marks for course 1, course 2, until course m. I want to know number of, I want to know whether, I want to just simply plot and visualize. How to plot? If I have C1, C2 until C3, I can plot into R3, three-dimensional space, right? If I have C1, C2, I can still plot in R2. But I have until CM. How to plot now? How to visualize and see the pattern of this student? Cannot, right? So we will reduce the dimension. Rather than using until C1 to CM, I want to see what is the significant dimension that I can embed this data in. I can actually reduce to R2 and then look at the structure of the data or the pattern of the data. Okay, that's called dimension reduction. Basically, we are reducing the dimension from RM to R2, for example. There are also some other methods called association, right? And then anomaly detection. So association, like this, you can see in supermarkets, right? Those who buys milk, they might end up buying baby's diaper as well. They will put next to each other. Right? That is association. If you buy milk, and probably you'll buy diaper also, right? So they will put next to each other. That's called association. Anomaly detection simply means that you want to find that individual or that one data which is very different as compared to the rest of the data in your table, right? One instance or one observation that is very different, but not noise, but real data, but very different. So those are anomaly detection problems. Okay, semi-supervised is a mixture of both. Yeah, a mixture of these two. You teach to certain level for it to do a model. Okay, examples. Yeah, examples. Reinforced learning, I just told you earlier. Okay, so it's a matter of giving reward and then penalizing it so that it learns over time. So a lot of robotic movements are based on reinforced learning. Okay, so these are examples, more examples on reinforced learning, but we do not cover in this course. Okay. Okay, questions for you to answer a little. Okay. Next is a little bit more on classification and regression.